So Chapter 2 will be a review in a lot of ways. We're going to be looking at categorical and quantitative data. You're going to talk about different classification methods. We had a short lab that worked through that. You're also going to do a little bit of classifying with raster data, and you'll find that raster data could be quantitative or categorical as well. I want you to go through that, but that's not going to be the focus of this chapter. So she's going to go over again some data types, creating maps using the different types of data, displaying raster and image data, and then how do you save documents. She'll go through again kind of setting relative pathways and the difference between using a feature class and a layer. So Price has a little different classification or data type nomenclature. She divides data into nominal, categorical, and numeric, and then ordinal kind of floats out there. She puts it under the categorical, but you map it as numeric. So I think as long as you can identify what kind of data it is, I'm not so focused on where it fits. So basically nominal data is used to label something. Categorical data is data that has been grouped into some kind of subcategories or smaller categories. Numeric, two kinds of numeric data, either interval or ratio data. And then ordinal is a lot like categorical because you do typically you take numeric data and divide it into groups or bins, but because they have a high value and a low value, you tend to map them as you would any numeric or quantitative data. So nominal data, basically she's talking about a text field. It's probably 90% that data will be a text. It identifies a name, attribute for a state, a county name. Census data has unique identifiers called FIPS codes, stands for Federal Information Processing Standard. Often these are numbers, but the way they align in ArcGIS will let you know that ArcGIS is seeing them as text, so you can't sum up the FIPS code numbers. You will get an error message with that. You can use them to map for labels. You can also use them as identifiers for querying information or querying data. So I'm looking at a nominal attribute table, and you'll notice that text is left justified or aligned on the left. This is numeric data, and it is justified and aligned on the right. If I had expanded this, you would see that the FIPS code is also aligning to the left. This is a really nice thing to think about when you import an Excel table or a spreadsheet and you intended the data to be nominal, and it might import actually as text, and you'll see that by the alignment in the table. Categorical data, so you might have 50 states and you divide them into 4 different categories, or you might have counties and you divide them into basic population types, whether it's commercial, rural, or suburbs. You also, the word type will also often be in the category name. Types of vegetation, types of geology, types of soil, any of that naming convention gives you a clue that you're dealing with categories of data. Again, the attribute can often be a text field, but sometimes the attributes can be numbers, and the number will have a key. And sometimes people will enter a number in ArcGIS, and I can choose when I set that up whether it's going to be seen as text or a short interval. Yeah, but I may intend it to be used as text, but I may enter it as a short interval number. So you can't always judge by that as to how the data is supposed to be used. And you can look at these as maps in unique values. So when I look at this attribute table again, there's a volcano type, there's subregions, so the type of volcano is very helpful. Here's a text field that would be used, the name field, of course, for labels. I could use either of these for querying. I could query specific names of volcanoes, or I could query specific types of volcanoes. When I bring categorical data in, the default for ArcGIS is kind of unique features, so every feature in that feature class gets symbolized the same. And to change that symbology, of course, you go into the properties and you're going to choose a category feature, and then you choose the value feature as a subregion. When you choose categories, you really want to be choosing data that has a unique individual color scheme, because my goal is to be able to identify one feature from another and have the sense that there's no value or hierarchy to these colors. They're just random colors assigned to these unique different regions. Now, if I were doing vegetation, I might want to think about, or land cover, I might want to think about using colors that kind of represented the natural environment, but they would not be valued or graded colors. Ordinal data, I'm going to go ahead and put it here. Typically you're ranking on some quantitative measurement, whether it was the highest crime rate, or the highest number of crimes, or the highest population, that kind of beginning data, but you've divorced your ordinal data from that number, and you've just kind of put things into rank or into groups. But because they have a hierarchy value, you can map them as you would quantitative maps using kind of that color ramp. So I don't know why this is here. I think it's to show that this is probably oh, wait a minute, I can't read the label. So the states have been ranked by some kind of value, and I cannot. Population ranking. Okay, so obviously very low populations and higher populations, so the color has some value. Here is geology filtration rates, and if I were just showing you the geology filtration type, I would not use a color scheme of light green to dark green, but because it's an ordinal data and a ranking, you can add that in. Numeric data, you're going to look at ratio data, which has a meaningful 0. So the 0 in that data means that the feature does not exist. It makes sense to add divide. Interval data, the 0 has been placed arbitrarily. There are only a few examples of this. Elevation, pH, temperature. And you map these with graduated color, making choropleth maps. So here's some numeric data fields. Again, you can see they're all right justified, indicating these are full numbers. So 0 means that there were no known eruptions of that particular volcano. So it's a valid data field. Again, they come in originally as unique fields. I'm looking at unique features as counties. So I go into quantities, and I'm going to map graduated color. I can set the number of classes. I can choose the classification scheme over classify, and choose OK. And this data was, let me go back here. Yeah, this data was actually normalized to show the percent of the population that is ages 5 to 17. And this data was normalized by the area of the county. Don't know why I did that. So then she's going to talk a lot about classification methods. There's 3 or 4 that you use more commonly than others, but basically it's how you're going to divide that data up to be shown on a map. And we're really talking about quantitative data here. And so the first method is called the Jenks Natural Breaks, and this is the default for ArcGIS. Jenks, so here's the classification. So there's a couple, maybe one county that has population in this area, and there's a lot of counties that have population down here below this blue line here. But basically it's trying to kind of look at the natural gaps in the data and map it accordingly. In this particular data set, there are over 2,875 counties have data less than 3,000. I don't know what. Yeah, I did a selection. Oh, I'm sorry, I cut that off. We'll have to just do that in class. But most of the counties, as you can see, fit in this 3 to 38,000. So most of the counties in the U.S. have less than 38,804 people or children in that age range. So it's really important when you look at that kind of data to maybe do a normalizing. And this is a normalized that age group by the total population. And I just created a new field rather than use the default here. But so I took the total number of 5 to 17-year-olds by the total number of the population. Now you need to normalize data, you need to divide that subset by something that is part of the greater whole. So you can divide that subset of kids by the total population. You could divide it by the total area because they're all part of that initial data. You couldn't divide the kids that are 5 to 7 by the number of people 20 to 30. Those populations are not joined in that total whole. Okay, another method is called, there's the natural breaks normalized by all the total number of 5 to 17-year-olds. The other method that she talks about is quantile. Quantile divides all of the features into whatever number of classifications you want so that there's an even number of features in each classification. And this is really good if your data is pretty linear from, just a nice straight low to high grouping, and it will help pull out some of those hidden groups. Equal interval is not good for this kind of data. It's really good for income and precipitation. The data ranges or classes are very even and they're easy for people to understand, and so often people don't understand a natural breaks and they think you're trying to be sneaky with that. Another method that's pretty fun to use is the standard deviation, and what this shows is kind of the outliers. So it figures out the average, in this case the average number of 5 to 17-year-olds for the entire country, and then it maps each county as to whether it's kind of above that average or below that average. And so it kind of shows where the white countries are the average and the brown are the lower average and the dark blue shows the really higher, so the way more than typical number of kids that age. So she'll go through that, and then she's going to end up with how to set a second data frame, going into layout view, what's your active frame, and again absolute and relative pathways. So for most of you a little more detail but pretty much review.